Greetings, everyone. In July 1940, during World War II, Germany devised Operation Sea Lion to swallow Britain whole. After the swift victory in France, Adolf Hitler planned to launch a naval assault from France, crossing the English Channel to land troops on British soil. However, this plan faced a major obstacle. Most of Germany's landing craft were small and couldn't withstand the Atlantic Ocean's large waves. As a result, Hitler shifted focus to the air front, aiming to gain air supremacy over the English Channel. Yet, the Germans were met with fierce resistance from the Royal Air Force, forcing them to postpone the operation. Looking back at history, there were two things Adolf Hitler failed to accomplish during the height of his power. He couldn't conquer the Russian winter. He couldn't cross the English Channel. The Channel, though merely a strip of sea dividing Britain from mainland Europe, somehow became a natural barrier that helped repel invasions from across the water. However, in today's economic conditions, this very separation poses a challenge for the British. The English Channel is a long stretch of sea in the Atlantic Ocean, located between the island of Great Britain and the northern coast of France. It measures 562 kilometers in length, with a maximum width of 240 kilometers and a narrowest point of 34 kilometers. In 1802, an engineer for Emperor Napoleon I of France, Albert Mathieu, proposed the idea of building a tunnel beneath the English Channel. He envisioned it as an underground passage with ventilation shafts and oil lamps for lighting. However, the plan was immediately dismissed as impractical at that time. In the 1830s, another French engineer, Antoine de Gamond, began geological and hydrological surveys between Calais, France, and Dover, UK. It wasn't until 1856 that he submitted a plan to Emperor Napoleon III for a railway line from Greenez, France to Folkestone, England. Yet again, the project was opposed by British public opinion, fearing it would provide an easy path for French troops to invade Britain. In 1875, the plan to link Britain and the continent was revived and debated again. By 1881, the project took a step forward as both nations began drilling tunnels from their respective sides. However, once more, the British concerns over national security caused the project to be abandoned, even after drilling over 1,000 meters. Not until 1955, when technological advancements had elevated air power and diminished the role of ground invasions, did the old security arguments between Britain and France begin to lose relevance. Paris and London resumed technical and geological surveys for the underwater tunnel project. In 1974, construction began on both sides of the channel, funded by both governments. But by January 1975, the British government cancelled the project again. At the first Anglo-French summit on September 10, 1981, a new proposal for either a bridge or tunnel across the channel was jointly endorsed by French President François Mitterrand and British Prime Minister Margaret Thatcher. After discussions, the final decision was made to construct a rail tunnel, known as the Channel Tunnel. Nearly 5 years later, on February 12, 1986, the Canterbury Treaty was signed under the witness of Mitterrand and Thatcher to officially begin construction of the tunnel. But even then, the journey of this tunnel of the century was far from smooth. It wasn't until July 29, 1987, when both leaders signed the Franco-British Agreement to allow construction of the Channel Tunnel, that the dream of linking the UK to mainland Europe finally became a reality. The approval process for this project was extremely challenging, and the organizational structure for building the tunnel was highly complex. Most of the funding came from the private sector. From the beginning, the British government made it clear that no taxpayer money would be used for the project. The tunnel was a joint venture involving 2 banks and 5 construction firms from the UK, 3 banks and 5 construction companies from France. In total, 10 construction companies and associated financial institutions formed a parent company called Eurotunnel. The first key factor determining the success of this megaproject was to identify the right geological layer for excavation. The tunnel was not built through open sea but within the seabed beneath the ocean floor. Geological surveys revealed that beneath the English Channel lay an upper layer of white chalk, a middle layer of blue chalk, a bottom layer of yellow clay. Engineers chose the blue chalk layer, which lay just above the seabed, to drill and construct the tunnel. The challenge beneath the channel, building the channel. The main reason engineers chose to tunnel through the chalk marl beneath the English Channel was its water-resistant nature and ease of excavation. However, the harsh terrain posed a colossal challenge for the tunnel workers. The design of the Channel Tunnel, or Chunnel, called for 3 separate tunnels, 2 rail tunnels, each 7.6 meters in diameter and spaced 30 meters apart, one for trains heading to France and one for those returning to England. Between them lay a smaller service tunnel, 4.8 meters in diameter, used for maintenance, technical operations, and emergency access. Every 375 meters, cross passages connected all 3 tunnels, serving both as ventilation shafts and escape routes. Construction officially began in 1988, 1 year after the Anglo-French Treaty was signed. The plan was to dig from both ends and meet in the middle. The British team began their work from Shakespeare Cliff near Dover in Kent, while the French started from Sangatte in Pas-de-Calais. Each side recruited around 4,000 workers, including surveyors, engineers, mechanics, electricians, welders, drillers, and tunnel diggers. The construction sites operated in 3 shifts, 24/7, over 6 years. At peak times, as many as 15,000 personnel were working on the project. Sadly, 12 workers lost their lives during construction, 5 French and 7 British. The tunneling machines were custom-built limited edition models, 11 in total, manufactured in the US and Japan. 6 were used on the British side, 5 on the French. Each machine cost roughly $42 million in 1988, about 2,500 billion VND today, and was a feat of engineering in its own right, 200 meters long, the length of 2 football fields, weighing 1,000 tons, heavier than London's Big Ben. If stacked, all 11 machines would be 5 times the height of the landmark 81 skyscraper in Vietnam. Each turn of the machine's massive cutting heads removed 10 tons of rock and soil. The machines ran at full capacity around the clock, with 35 engineers and operators assigned to each. Precast concrete segments were brought in and installed immediately to line the tunnel walls. These panels, reinforced with granite and weighing more than a truck, numbered over 1 million and formed walls even stronger than those used in nuclear power plants. Despite meticulous geological surveys and state-of-the-art equipment, both teams faced daunting setbacks. The French side encountered unstable ground riddled with fissures, allowing seawater to seep into deeper layers. As a result, they could only operate 2 machines at a time to maintain safety. They eventually had to bring in experts from Japan and the US to stabilize the site. Meanwhile, the British took full advantage of their dry, solid rock layers, running all 6 machines simultaneously. After 1 year, the British had bored through 4 kilometers of tunnel, 4 times the French progress of 1 kilometer. But in 1989, the British team hit a major obstacle. Seawater flooded part of their tunnel for 9 months due to the lack of concrete lining at the base. Engineers had to inject grout to seal cracks caused by the tunneling, and at times, they dug ahead manually to detect and reinforce weak spots. Beyond physical challenges, there was another major concern: precision. Since GPS couldn't be used under the sea, how could they ensure both ends of the tunnel would align perfectly? A miscalculation could spell disaster. To solve this, engineers used laser-guided navigation systems and relied heavily on geological expertise. The French side achieved greater surveying accuracy, while the British tunnel deviated by about 4 meters. Upon realizing this, the UK team scrambled to realign their path. Despite their efforts, anxiety loomed. No one could be certain what awaited on the other side. Then came a historic moment. On December 12, 1990, while online shoppers today might recognize that date for year-end sales, it marked a monumental achievement beneath the channel. 2 years after the project began, British and French tunnels finally connected. Cheers and tears erupted as engineers Philip Kett, France, and Graham Fagg, UK, met at the breakthrough point. At precisely 12:12 and 12 seconds, under the eyes of the world's media, the two shook hands inside the tunnel that now physically linked Britain and mainland Europe. BBC called them the first to cross the English Channel by land. What's remarkable is that the 2 tunnels were only misaligned by 6 centimeters vertically and 35 centimeters horizontally when they intersected, a deviation that was acceptable and fixable. By that time, France had dug a 15.6 kilometers section and the UK had dug 22.3 kilometers, overcoming numerous challenges. Finally, on May 6, 1994, after 6 years of construction, Queen Elizabeth II and French President François Mitterrand officially inaugurated the Channel Tunnel at Calais, France. The Channel Tunnel remains the world's longest underwater tunnel, stretching 37.9 kilometers under the sea, with an average depth of 50 meters below sea level, and its lowest point at 75 meters. The project cost $21 billion in 1994, equivalent to about 1 trillion VND at the time, and exceeded its budget by 80%. France began service operations in November 1994. There are three types of trains operating in the Channel Tunnel: Euroshuttle for transporting vehicles across the channel, Eurostar for passengers, and freight trains. It only takes 35 minutes to travel through the channel, compared to over an hour and a half by ferry. All services in the tunnel, including the trains, are powered by electricity, split evenly between the UK and France. In 1995, 1 year after the Channel Tunnel began operations, 7.3 million people had crossed the English Channel. By 1996, the American Society of Civil Engineers recognized the tunnel as one of the 7 modern wonders of the world, alongside other famous landmarks like the Empire State Building in the US, the Ipu Hydroelectric Dam in South America, the CN Tower in Toronto, Canada, the Panama Canal, and the Golden Gate Bridge in San Francisco. However, despite its modernity, the tunnel has not been without its issues. Since its opening, there have been 3 fires in the tunnel, causing significant damage and resulting in temporary closures. The first and most serious fire occurred on November 18, 1996, when a blaze broke out in a car-carrying Euroshuttle train. Fortunately, there were no casualties, but the fire damaged 500 meters of the tunnel, disrupting operations for 6 months. On August 21, 2006, a truck on a Euroshuttle train suddenly caught fire, forcing the tunnel to close for several hours. The third fire occurred on September 11, 2008, when another blaze broke out on a Euroshuttle train, just 11 kilometers from the French terminal. Thankfully, there were no fatalities, but several passengers were hospitalized due to smoke inhalation. The tunnel section where the fire occurred was immediately closed to all traffic, and only the remaining routes continued to operate. It wasn't until February 2009 that the Channel Tunnel was fully operational again. As the saying goes, a good start makes for a smooth finish, but this might not apply to this billion-dollar tunnel. Although the tunnel's operations returned to normal in early 2009, by the end of the year, specifically on December 18, 2009, 5 Eurostar trains carrying passengers broke down, trapping 2,000 people in the tunnel for 16 hours in conditions with no electricity, food, or water. While the tunnel has successfully linked the UK and France, contributing to the development between the two countries, it has also exacerbated a long-standing problem in Europe: asylum seekers and immigration. Since the tunnel's opening, a large number of people from Afghanistan, Iraq, Iran, Africa, and Eastern Europe have attempted to board freight trains to enter the UK. Some even waited for the trains to pass so they could jump onto the Eurotunnel trains from bridges. The company operating the Channel Tunnel reported that it had prevented over 37,000 asylum seekers from crossing between January 2010 and 2020, leading to delays on train services, damage to railway equipment, and an estimated loss of over £5 million per day. However, after Brexit, the UK's departure from the European Union in 2020, travel conditions via the Channel Tunnel have changed. Instead of free movement as before, starting in 2024, UK citizens wishing to travel to France and other EU Schengen zone countries via the Channel Tunnel must have a passport, an electronic travel authorization (ETIAS), and a visa for stays over 90 days within a 180-day period. Similarly, the UK will introduce a similar electronic travel authorization (ETA) system for citizens of the Schengen area. At the same time, Schengen citizens will only be exempt from visas for stays of up to 6 months. Nevertheless, the Channel Tunnel remains a monumental achievement, showcasing the pinnacle of human engineering, technology, and creativity. It is not just a symbol of cooperation and friendship between the UK and France, but also a historic milestone that broke the natural barrier between the island of Great Britain and the rest of Europe. If you found this video useful, please share it and give it a like. On the screen are other interesting videos for you. Choose one and click to continue enjoying. See you in the next video.